So I want to take a minute here and talk about turning in the homework, because it seemed like the homework submission was a little bit shaky, and I'm guessing there's a technology component, at least for some of us, and like, how do I go about doing that? So I'm just going to do like a sample of me doing that. Now I'm going to show you like one way to do this. Ask around some of your other friends that are also had me in class or currently have me if they have a better way than what I'm going to show you. I'm just going to show you one way that's like the most basic of basic ways to do this. Okay? So if I have homework that's done on a separate sheet of paper, and I want to get this image into my OneNote, I'm going to take my cell phone, because my tablet camera is pretty terrible, and I'm going to take a picture of this. Now there's lots of different ways you can take a picture of it, depending on the file format you're looking for. What I like to do is I like to go into Notes, and I pick like something from my iCloud folder, and then make a new note. If I pick the little paperclip guy, one of the options is Scan Documents. And I just kind of hold it over and it just beep, boop, 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 beep, and like scans the thing so I don't get any surrounds. And then I just, I hit save down at the bottom, and then I do the little upload arrow. And I'm just going to email this to myself, so I'm going to email it to my Notre Dame account. Is everybody okay with what I'm describing? Feel free to follow along and do this yourself if you have stuff that you need to get in there. So I just emailed this to myself. Again, you can take a regular picture or whatever. It doesn't really matter the file format. I like to do the scanner because then you don't get anything extra other than your sheet of paper. And then it's a PDF format that's nice to use later on if you have to use it for anything else, which I don't think you would really ever have to do. So I just emailed that to myself. I'm gonna get an email, which doesn't really seem like it's gonna come through real fast, which is just super cool, right? How slow sometimes the internet is. That's okay. I'm just gonna use this email that has an attachment on it. So pretend this is the paper. I got it from the email. I just clicked on the attachment. And the easiest way now to get this into my OneNote is I'm going to press the print option. And for whatever reason, it makes you do it twice. And from the drop down here where it says destination, I'm going to pick OneNote Desktop. If it doesn't list it, you'll have to do See More, but it should be one of the options there. So I do that and I hit print. And it now will prompt my OneNote and says, okay, where do you want to save this to? And let's just say, for example, I'm Adriana, and I'm going to save it my homework. So I find my name, I go under homework, and I say okay. And now if I look under Adriana's homework, there's the thing for my attachment. And it's in there and it's done. And I don't have to download anything. I don't have to keep the file. I can delete the email after I've done it. Yeah. Next.
The hard note to do is it was 2.1 1 through 24, right?
Yes. Yes. Does that help you guys? So the where you're putting it is under your name in your homework tab in the OneNote, right?
It's Jake.
Jake.
When before the weekend, I had to clear a bunch of space in my computer, so I went to IT.
Okay.
And I wiped out a bunch of stuff.
Okay.
So I lost basically all my OneNote, so I did even this and this.
Okay.
I'm not in the OneNote for this class right now. So
Okay.
I need to get in there so I can zoom in.
So did you sign up initially at the start of the year?
No, I couldn't sign up initially.
Okay.
So for the first time I had been able to.
So let's talk after class, and I'll make sure that we'll figure out what's going on. I'll get you signed in and figure out what we need to do. Okay. But don't let me forget.
Okay. Yeah. No, I'll come up to you.
Okay. Perfect.
We're supposed to do the problems in it or the worksheet?
So there were two things that I was looking for. I was looking through the 1 through 24, and that worksheet that you guys did as the first day, that should have been in there also.
In the OneNote?
In the OneNote. Yep.
Actually, I didn't last night.
Yeah, if it was already in there, it's fine. It stays in there. So like if I go and I look at Lucas's OneNote, like he's got his day 1 in there, and now he's got a new homework set in here, and another one that's coming in. And I like how Lucas has done this, where he's doing a separate page for each assignment. That's super helpful on my end for me in telling what you get, what I'm getting, or what I'm looking at. Some of us dump everything into the same page, and then it becomes really overwhelming trying to figure out what's what. Especially if you're not labeling the top of your paper with like, what is it? What is this I'm looking at? Do you guys feel okay?
Yeah.
Okay. Remember, what's the late work policy for me?
1 week.
You have a week of grace, so I'm going to grade everything that first day back, or at least as much as I can that first day. Maybe it's the first day or 2 back. So like Monday or Tuesday or whatever. And whatever I can see, I'm going to grade. Anything I can't see or that isn't all the way there, I'm going to mark missing or incomplete. You have a week then to kind of fix what's going on and shoot me an email, whether it's I had to finish something or I just didn't get it uploaded, or there's a technology issue and something didn't sync through the right way, or whatever. There's no penalty on that. You don't have to do anything. You just fix what's going on and send me an email to let me know to go back and check it again. Madison?
Where would you find the 1 to 24? Because I couldn't find anything.
So if you look in the content library, if you look at Chapter 2 problems, that's the list of the homework problems that we'll be assigning through Chapter 2.
Oh,
Okay. Yep. Max, what's up?
So take a picture, email it to yourself,
And then from that email attachment, you print to OneNote.
and then do I send you another email after that?
You would send me an email to let me know that you fixed your missing, and for me to go back and check it.
Okay, well, can I still can I do this on? You said you do it on my phone too, right?
Yeah. Yeah. And I know some students, I think, have a OneNote app on their phone, and they do it inside of the OneNote app on their phone. That's fine if that works for you, if you figure out how to do it. Like, I'm totally fine with that. I'm just showing you, like, with minimal app usage, what to do, where you just take a picture, email it yourself, and then print the attachment into your OneNote. It's the simplest, well, like, maybe I had simplest in terms of steps, but, like, the simplest in terms of technologies needed. Questions on that? Did that help those of you guys that had questions about how to submit the homework, or where am I turning this into, or where's the homework at, or any of these things? You feel better?
Yeah.
Nick?
So the 1 through 24, and then that worksheet, we got it.
Right, that was what I was looking for on Sunday at midnight or whatever. We already assigned like the 25 through 30. Eventually it'll become like 25 through 42, I think, is what the minor name says in terms of what the next problem set's going to be. We haven't gotten to that part yet. We'll do that today.
There's 25 through 30. Or was that was 25 through 34? 42.
Eventually it'll be to 42. We didn't finish the two notes last time. So we'll eventually do all of those. And if you've done them all, that's fine.
Okay.
They will be assigned. You're just a little, sometimes I'm guessing as to what we're going to get through in class and that kind of thing when I put in the assignments and stuff. So
I think.
that's the other part of having like a week of grace. It's just like, saves me from like when I screw up a due date on something also. That like everybody's giving each other, the benefit of the doubt on all this. Does that feel okay?
Yeah.
Okay. So my plan today, we're going to finish up section 2.2. We're going to do section 2.3. I'm going to stop there. We'll do a little bit of like, so, all right. Finish 2.2, do 2.3. We're stopping there. You guys have a delta math assignment in addition to some book work. But that's, 45 minutes to an hour. So you have like 20 to 30 minutes here at the end to kind of pick away at stuff. If there's questions about homeworks, I'll take those all at the end. And, if you're not interested, it'll give you time to work on Delta Math or homework or whatever if you're not interested in homework questions about the previous stuff that was due. But I'll do that at the front after I've kind of gotten through everything and gotten everybody else something else to work on. Sound good? Okay.
Yeah.
All right. So last time we had left off in section 2. So in section 2, we had talked about SOHCAHTOA, right? That was a thing that we remembered from geometry. And we had introduced the idea that, okay, so sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. But why isn't there, hypotenuse over opposite? Why isn't there a name for something like that? And it turns out there was. We just didn't tell you about it in geometry. So we introduced the 3 reciprocal trig functions, cosecant, which was the reciprocal of sine, secant, which was the reciprocal of cosine, and cotangent, that was the reciprocal of tangent. And then we're just kind of bulldozing through some examples, getting used to using those 3 new trig functions inside of right triangles. So this next example says, let theta be an acute angle of a right triangle. So there's a right triangle. I'll label one of the angles as theta. It says if sine theta equals 1/3, find the values of the other 5 trigonometric ratios for angle theta.
Is this a 2-1-3?
This is 2-2 still. We're finishing 2-2 right now. We still had a little bit of example left to do in there, and then we'll do 2-3 after.
Oh, yeah, exactly. So there's-
Yep. So I remember from SOHCAHTOA that sine is opposite over hypotenuse, right? So I know that the opposite side of this triangle should be labeled 1, or should have length 1, and the hypotenuse of this triangle should have length 3. So I go over to my picture, and I look at my angle theta. Relative to the angle theta, this side is the opposite. This side is hypotenuse, so this side is the adjacent. So the hypotenuse has length 1, opposite has length 1, hypotenuse has length 3. I'm going to call the adjacent side x. To be able to complete all the trig ratios for this triangle, I'm going to need to find that side x. The easiest way to do that would be Pythagorean theorem, right? So the Pythagorean theorem says in a right triangle, a squared plus b squared equals c squared, where c is the hypotenuse. So I'll say 1 squared plus x squared is equal to 3 squared.
Mr. Fuller,
Yes, sir.
once we're done with this one, is there any way we could do one where the hypotenuse is what we're trying to find?
It's like, I don't remember what other the examples I have, but it's like the same problem, isn't it?
Is it? I was saying where it's like, oh yeah, I guess it is.
You don't have you have less algebra to do.
Right.
This is the more complicated one.
Okay, that makes sense.
Are you okay?
Yeah, no.
Okay. I don't want to say no, we can't do that. It was just I was unprepared for that question at this point in the problem. All right, so 1 squared is just 1, 3 squared is 9. Oops. We subtract 1 from both sides, so x squared is 8. Square root both sides. When we square root both sides of the equation, what do we need to remember? Plus or minus, only 1. Now, This x represents what?
The side.
The side of a triangle. Can a side of a triangle have negative length?
No.
No. So we're just going to drop the negative, right? Because that can't be. And we want to probably simplify the square root of 8. What does the square root of 8 simplify to when we reduce that radical? 2 square root 2, right? So you get like, so 8 is just 4 times 2. So square root 8 is square root 4 times square root 2. And square root 4 is just 2. So you have 2 root 2. So far, so good? Okay. So it asks for the 6 other trig ratios. So let's start with cosine and tangent. From SOHCAHTOA, I know that cosine is adjacent over hypotenuse. If I look at my triangle, the adjacent side is 2 root 2, and the hypotenuse is 3. So I can just write those in. Everybody happy there? Tangent is opposite over adjacent. So the opposite side is 1, and the adjacent side is 2 root 2. But uh-oh, what's going on this one that we don't like?
There's a thing in the bottom.
Yeah, the square root in the bottom. How do we take care of that?
You do like 2 square root on top and bottom.
So we multiply by the conjugate, is the term that we're looking for here. I'm going to multiply the top and bottom by just the square root of 2. Okay? You could do 2 square root of 2. That's not wrong. You're just going to have reducing to do at the end that you avoid by just doing the radical part. So 1 times square root 2 is just square root 2. Square root 2 times square root 2 is 2. And then times the other 2 is the 4. Everybody so far so good? Okay. Now we'll do the other 3. Cosecant, secant, and cotangent. So the abbreviation for cosecant was CSC. The abbreviation for secant was SEC. And the abbreviation for cotangent is COT. So there's kind of 2 different approaches I can take here. So I can remember that cosecant is hypotenuse over opposite. Or I can just think about it as the reciprocal of sine. I know what sine is, so I'm just going to make the reciprocal, which is 3 over 1, or just 3. Done. Nothing more to do. Secant is hypotenuse over adjacent, or just the reciprocal of cosine. So the reciprocal of that but what do you notice?
Can't have that on the bottom.
Yeah, oh, got to rationalize the denominator. Oh, bummer. That's okay. Do it the same way. So we have 3 root 2 over 4. And then cotangent, again, is adjacent over opposite, or the reciprocal of tangent. Now, it's tempting to just take the reciprocal of this. You could, it's not wrong, but you're going to have more work than you need to. What you want to do is you want to take the reciprocal before you rationalize. Just saves you some algebra. What's the reciprocal of 1 over 2 root 2? Just 2 root 2, right? And we're done. Woo! That's not bad. So thinking about those guys as reciprocals just kind of speeds up the process, right? Doesn't matter how you want to think about it, though. Either way of doing it is fine, but I like thinking about them as reciprocals. It's just less memorizing. And like, is this what over what? Like, it's the reciprocal of the other one. So far, so good? Okay. I think I got some more. So if I ask you to find sine of 17, how are we going to go about doing that? Sine of 17 degrees. Can you do that by hand? No, it's just a calculator problem. That's what I want. It's this guy right here. No. You go away. So, if I'm about to use my calculator to do a sine, cosine, or tangent problem, and I haven't used this calculator to do this kind of thing in a while, or I'm borrowing someone else's, or I let someone else use mine, I'm getting it back, the first thing I want to do before I start typing anything into my calculator is to check the mode. Your calculator has two ways that it's going to measure angles: degrees and radians. This problem, if we ask to do the sine of 17 degrees, our calculator needs to be in degree mode. So I'm going to press the mode button, which is right next to the blue second key. And I'm going to go look down at that option 4 that says radian or degree. I'm going to move my cursor over so the degree is highlighted and press enter so that it looks like my screen looks here. Everybody okay? Great. And then I'm going to exit out of here. So I just press second in mode. That'll exit you back to the main screen. And now I can just type sine of 17. It'll always be between -1 and +1.
Really?
Yep. So there'll always be small numbers. Everybody okay there?
Wait, I got a negative number.
So you're still in radian mode.
So,
Press the mode button. The fourth option down
I want to
is
be
degree
a
or radian.
degree.
You want to be in degrees.
Okay.
Max.
Do you have a charger for calculators?
Yeah, there's one in the power strip here at the desk. Feel free to plug yours in. You can borrow one off the stack on the desk if you want to use one in class.
Yeah.
But you're welcome to do that whenever. Got it. Okay. The other was secant of 78. You guys look at your calculator. Do you see a button for secant?
Yes, I do.
You shouldn't, because there's not one there.
Oh, I thought it was the sine -1.
Nope. So those are.
Oops.
So that's a common mistake, because sometimes we use a -1 exponent to mean reciprocal, and sometimes we use it to mean inverse.
Oh.
So the sine, cosine, and tangent with the -1s are inverses, not reciprocals. It's a different thing. So I don't have a secant button on my calculator, but I do remember that secant is the reciprocal of
It's
cosine. So I know that, right? Secant of 78 just must be 1 over cosine of 78. And that I can type into my calculator. So I'll just do 1 divided by cosine 78. I'm not bothering to check my mode again because I just checked it to make sure I was in degree mode. So I don't need to check it every single time. I just turn it on. I'm going to check once. And really, if it's my calculator just been sitting in my backpack, that mode isn't changing unless your calculator gets reset for whatever reason. So once you've switched it, it should stay switched. Unless catastrophe strikes or something. Does everybody feel okay about using your calculator to get sines and cosines and secants and cosecants and cotangents and stuff? Okay. Now, there are some angle measures where I could expect to get an exact answer. I could ask you for an exact answer. By exact, I mean no decimals. The only 3 angles right now that I can ask you to do this for are 30, 45, and 60. What's special about those 3 angles that is going to allow me to get an exact answer? If you remember back from geometry, there were 2 special right triangles. There's a 30, 60, 90. And a 45, 45, 90 right triangles. And what was special about those right triangles is that their side lengths exist in ratios. So in the 30, 60, 90, the short side, I'm going to call has length A. The medium side is going to be the square root of 3 times A. And the long side will be 2 times A. Is this ringing a bell? Yeah. Okay. Again, I don't expect that you remembered the ratios or where they went, but a 30, 60, 90 triangle should ring a bell that there are ratios and like we did stuff with that. And the 45, 45, 90 triangle, because 2 of the angles are the same, I know that's an isosceles triangle. So the 2 leg lengths should be the same. So give them both length A. And then the hypotenuse is going to be the square root of 2 times A. So now if I wanted to do like cosine of 30 degrees, I would do adjacent over hypotenuse, reduce out the A's, and there's an exact answer. If you type that into your calculator, cosine of 30, you're going to get 0.866, yada, yada, yada. If I type in the square root of 3 divided by 2 in my calculator, I'm going to get the same 0.866, yada, yada, yada. Those 2 answers are equivalent, and that's a way to check to make sure you got it. It's just see if they both have the same decimal expansion. You guys kind of remember doing this in trigonometry, or I'm sorry, geometry, somewhat tree. Elm tree, oak tree, pine tree, I don't remember. Yeah. That's supposed to be a joke. Okay. All right. Example, or another example, it says solve the triangle. When I give the direction solve the triangle, what is that direction asking us to do?
Find the missing side.
Missing side lengths and missing angles. So there are 3 things I'm needing to find in this because I have 2 unknown side lengths and 1 unknown angle. I'm going to call the unknown angle theta, and then the unknown sides x and y. Again, this convention in trigonometry is we name our unknown angles with the Greek alphabet and our unknown lengths with the Roman alphabet. Everybody okay there? Again, you don't have to do it that way, like 3 different variable names is fine. You know, whether it's bird, panda, and taco, or whatever you're going to call your variables, doesn't really matter. They're just representing unknowns. I don't know anybody who's insane enough to draw like a little picture for their variables, but like somebody probably is going to eventually. Okay, so if I look at this guy, one of these 3, the x, y, or theta, I get basically for free. Which one is the easy one to get?
The angle.
The angle. And how do I find that angle?
You add the right angle plus the 41, which you already have, and then you take that sum and subtract it from 180.
Great. So I remember that there's 180 degrees in a triangle, or the corollary to that is that in a right triangle, the 2 acute angles add to 90. That's I think the easier way to do it, but what you said is completely correct and equivalent to what I'm saying. So I'm just going to do 90 minus 41. And there's my angle. Basically for free, right? I just had to subtract some numbers. No algebra really necessary. I had to remember an old geometry fact, but we probably, if push came to shove, would have been able to pull a triangle that has 180 degrees in it out of our back pocket, I hope, even though geometry was a long time ago. That's the one that usually sticks pretty good because you use it at So far, so good? All right. Now let's pick what side we want to solve for next. It doesn't matter which one you choose. We have enough information to do either one. So let's say we want to solve for x next. So now that I've decided I'm going to solve for x, I need to pick an angle that I'm going to use to do this. My choices are the acute angles. If I have my choice between the 41 and the 49, the one I'm going to choose is the 41. The reason is that the 41 was given to me in the problem. I know that number is correct. The 49 I had to find. There's a possibility I did something stupid and did some arithmetic wrong and got the wrong answer. I would avoid using any of my calculations to make an equation if I can, just so that if I have the wrong answer, it doesn't create another wrong answer for me later on. Everybody okay with that? Okay. So, relative to this angle, I need 2 side lengths. One of them is x that I've already chosen. The other one has to be the 12, because it's the only side I know about, right? So the x was opposite, the 12 was adjacent. So the trig function I need to use here is tangent. So I'm going to write that tan 41 is equal to opposite over adjacent. So that's the equation I'm going to solve. Let's do this. It's probably a little easier to see now, right? Start using that green, and it's like, boy, that's hard to see with the grid lines. Get rid of those grid lines for us, since I'm not drawing any graphs here. So far, so good? To solve that equation for x, what do I need to do to get the x by itself? Multiply both sides by 12. Sounds great. So I'm going to have x equals 12 times tan 41. Everybody okay that I just wrote the equation in the opposite order, so the variable's on the left? I didn't do anything sneaky there. I just looks wrong to have the x on the other side. And now it's just calculator time, right? Tan 41, that's not something I can do by hand. So let's pull up our calculator. So 12 times tan 41. So 10.43, let's say just round it to 2 decimal places. Everybody feel good there? So now we'll find the y. Now I acknowledge that I have 2 of the 3 sides in a right triangle. I could use the Pythagorean theorem to find the y, but I'm not going to do it that way. The reason I'm going to choose to avoid doing it that way is because it would require me using my answer for x. And what if that answer is wrong? Then y is going to be wrong also, right? I can solve for y without having to use my answer for x. That's what I'm going to do. So I'm going to basically repeat the same kind of process I used to solve x to solve y. So I'm going to choose to use the angle 41 because it's given to me. Luco?
Alright, 2 times tan 43 by 12.
I did 12 times tan 41 into my calculator, and that's where the 1043 comes from.
Okay.
So I just did it one line. And I'm going to choose to use the 12. So again, the 12 is the adjacent side. The y is the hypotenuse. So the trig function I'm going to use is cosine. So I'll say cosine of 41 is equal to adjacent over hypotenuse. So far, so good. To get the y by itself is going to be a little bit trickier because where is the y located here? It's in the denominator, right? What am I going to want to do to both sides here as my first step to get y by itself? Well, if I multiply 12 to both sides, I'd have 12 cosine 41 equals 12 squared over y. And it's not getting me any closer. Really, the first thing I want to do is get that y out of the denominator. So let's multiply both sides by y. That'll get the y out of there. Max. Sure. Yes, bathroom fine. Lucas, go ahead. Everybody okay so far? So that means I have y times cosine 41 equals 12. And now to get the y by itself, what should I do? What operation is going on between the y and the cosine 41? Multiplication in between them. So to get rid of that multiplication, I divide by cosine 41. Remember, cosine 41 is just some crappy long decimal, right? And I don't care what the decimal is, the calculator is going to tell me, but I don't even really, it's just an intermediate value for something I'm going to type in. I'm just typing in 12 divided by cosine 41, and pressing enter here. So I have 15.90. What do you guys think? Everybody all right? There's my x and my y. You guys feel okay? So far, so good? So this is what happens if you're given a side and an angle as you're starting. The other way we could give this problem to you is I could start by giving you two sides. So it's the same solve the triangle example. Here I've just given you different starting information, the different starting information being two sides rather than a side and an angle. I can't give you two angles to start. Can't do anything with that. But we'll start the same way. I'm going to start by just labeling my unknowns. So I'll call this guy theta, and this guy will call phi, and I'll call that guy, that side x. Again, phi is just another Greek letter. It's basically like you draw a circle and then you end with a downstroke through the middle. So one of these unknowns is pretty easy. We get almost for free. Which of those unknowns is it?
Hypotenuse.
The hypotenuse by using
Pythagorean.
Pythagorean theorem. Great. So, Joe, here's an example just for you where we're finding the hypotenuse. So if I do this, 5 squared is 25. 12 squared is 144. I add those together and I get 169. We'll square root both sides. When I square root both sides of an equation, I get a plus or minus, still just one person. The square root of 169 is nice because that's a perfect square. That's just 13. Ooh. And again, we're talking about a side length, so it can only be positive. Everybody feel good? Okay, that's one down. Now let's pick an angle to solve for. I'm going to choose to find theta first. It doesn't matter which one you choose. And I'm going to look at the sides that are given to me, because I'd rather use the sides that are given rather than what I found myself, because if I made a mistake, if I use a wrong answer, I'm going to get another wrong answer back. So I'm going to choose to use the 5 and the 12. Relative to theta, those 5 and 12 are opposite and adjacent. So that means I should be using the trig function of tangent. So we'll say tan theta equals opposite over adjacent. Now, how am I going to get that theta by itself? How do I get rid of that tangent out front? It's going to cancel that thing out. What do I have to do to both sides to get rid of that? Not divide, not multiply, not add or subtract, not square root, not an exponent. What I need is to use as a function composition. So I'm going to do some function to both sides. What function is the cancels out a tangent? It's not cotangent, but now you're getting closer.
The inverse.
Inverse tangent, yes, that's the tan to the -1. Remember we talked about that on our calculator being different than cotangent. This is where you use it. So the tangent inverse, all of these inverse trig functions, what they do is they turn a ratio of side lengths, like 12 over 5, into an angle measure like theta. So those guys cancel each other out. So into my calculator she goes. So tan inverse 12 over 5, I get 67.38. everybody, okay? So phi then needs to be just 90 minus theta, right? So what do I get? I get 31.62, I think. No, 32. Well, yes, 22. Good. This is why you do it on your calculator and you don't trust your own mental math. Yikes, or ruinies. Thank you, Mark. Keep on double checking me. Anytime you see a mistake, holler it out, loud and proud. I'll do the same thing to you guys if you do it wrong. You're like, thanks. Do you guys feel okay on solving triangles?
Yeah.
That's going to be the majority of your delta math. It's going to be like doing some of these right triangle problems from geometry, getting reaccustomed to this. Because today we're going to start dipping our toes into moving past these right triangle definitions of sine, cosine, and tangent, start building out a more expansive definition. The first problem that we have to deal with, though, is if I go back to geometry, the smallest angle you can draw is 0 degrees, right? The biggest angle you can draw is 180 degrees. You can't draw anything in between because in geometry we said we're always going to draw our angles this way and never draw our angles that way, right? Everybody's okay? So like 0 degrees or 180 both kind of represent the same kind of thing. So what we want to do here is we're going to come up with a new way of kind of defining an angle so that we can draw things that are bigger than 180. So to do that, we're going to embed our angle inside the xy axis. We're going to fix the vertex of our angle at the origin, and one arm of our angle on the positive x-axis, we're going to call that the initial side of our angle. We're going to take the other arm of our angle, and we're going to start that at the positive x-axis, and we're going to rotate that arm counterclockwise until we've crossed, in this case of an example, 190 degrees. Sure. So again, we're starting at the initial side, and we're going counterclockwise, and we're counting 190 degrees. How many degrees are in a quadrant? 90, right? So we're at 90, 180, and then like 10 degrees more. You just kind of eyeball it. So that's your 190 degree angle. When you draw these for me, I'd like to see the arc thing, like I've drawn in here. Okay? Where I'm placing that other side, we call this other side the terminal side, is just an estimate. So if you're in the correct quadrant, that's good. If you're like between 0 to 15 degrees, I'd like to see this terminal side a little closer to this end. If you're between 15 and 75, I'd like it to see it somewhere in the middle. And if it's between 75 and 90, I'd like it closer to this end. But that's as much of an estimate as I'm looking for. Just which one should it be closest to? Try to have it look a little closer to it. But that's good enough. There's no measurement going on. It's a real rough estimation. Is okay? So if I add up those 4 quadrants, how many degrees are in the 4 quadrants? 360, right? How am I going to do 405 here, which is my next one? Yeah, you just keep going, right? Exactly right. So we'll start at the positive x-axis on our initial side. 90, 180, 270, 360. Don't make a circle. I know how to make a circle. And then like 45 more. So you just keep going. Sure thing. You guys still good? So what have we just accomplished? Well, we now can write angles as big as you want, right? From 0 to as big as you want to make, I can draw that angle now using this process. We could not do that before in geometry, right? That's pretty cool. Drawing angles this way has a name. So like, we call these like standard position angles or angles in standard position. So just as a vocab there, talking about all these things. What if we wanted a negative angle? What makes sense to do for that? We just go the opposite direction, right? We rotate the opposite way we were going before. So this time clockwise, but we just go the opposite way. So instead of going counterclockwise, we're going to follow the clock. So 90, and then like 30 more is 120. So there's that. What have we just done now? Now we can do angles of any size, right? Positive or negative. You give me any real number, I can draw you an angle that has that size. Ooh, fancy. And it's pretty simple too, right? Like we haven't done anything, there's no calculation, just like drawing. Now, this looks simple. This is a core skill for everything we're going to do for like a few chapters here. Like if you can't draw angles in standard position well, it's going to be a problem over and over and over again. So this is a skill you really need to be able to do. It's not difficult, but you got to be able to do it. Everybody's okay? All right. I want to look at a special situation. So I'm going to draw a 45-degree angle and a 405-degree angle. We're going to observe something here. So for a 45, I'm just basically starting at my initial side and going like 45 degrees up. No big deal, right? I could do that in geometry. 405, again, I'm starting at the initial side. So 90, 180, 270, 360, and then 45 up from the initial side. What do you notice about the terminal sides in both of these two angles?
They look the same.
They're in the exact same position, right? They're just 45 degrees up from the positive x-axis. We're going to give this situation a special name. So we're going to call these two angles up here, we can call them coterminal angles. So those are angles that have different measurements, but the terminal side is in the same location. For example, 45 and 405. What do you notice when you subtract those two angles from one another? What do we get? 360. Does that make sense? Because what should the difference be between two coterminal angles? It should always be at least one rotation, right? So actually, coterminal angles should differ by some multiple of 360, whether it's going around one time and being at the same spot, or two times and then being at the same spot, or going in the reverse direction and being at the same spot. But that's the idea. Coterminal angles will always differ by some multiple of 360. Whether it's 1 times, 2 times, 3 times, or -1 times, -2 times, -3 times. So our final example here, I ask you to find two angles coterminal with 47. So if our angle is 47, our coterminal angle I can just get by adding 360 to it. And I can get a second coterminal angle by just taking that and adding 360 again. So just going around a second time. Or I could add 360 again and get another one and another one and another one. Or even I could have, instead of adding 360, we could have subtracted 360. You could do it that way. What do you notice about the number of angles that are going to be coterminal to a given angle? How many will there be? A lot. Specifically, infinitely many, right? You can generate coterminal angles your entire life and you'll never finish them all. It's a sad pursuit because you spent your whole life trying to accomplish something that was not possible to finish, but I could think of a worse way to spend your life. Part B says find two angles coterminal with pi over 3, I think is what that says. What do you notice about the angle pi over 3? It's in radians, right? So we'll still do everything the same way, but we can't add 360 degrees to radians. We'd have to add the 360 degree equivalent in radians. So if you remember back to 2.1, we said that pi radians was 180 degrees. That was our conversion factor. So how many radians are going to be in 360 degrees? 2 pi. 2 pi radians. So 2 pi is the 360 equivalent in radians. So we'll just add 2 pi. To add pi over 3 and 2 pi, what do we need to have? We need a common denominator, right? What would that common denominator be? 3. So we do like one of these guys, and 2 times 3 is 6, so I have 7 pi over 3. Is everybody okay there?
Yeah.
I kind of bulldozed through the common denominator thing, but I hope that's okay with everybody. I wrote it out, so you at least, you go back and look at your notes, you're like, okay, maybe common denominator. And if I need a second coterminal angle, what do? I just take that answer and I add to it another 2 pi. When you make your common denominator, you get 13 pi over 3, and you just keep on going if you wanted to, right? Or you could subtract if you wanted to. How do you guys feel? This is my stopping point. So at this point, you guys should be able to do now up through 44.
The thing of NDP, my NDP says.
I'm aware of what it says. So it's just because of the way that things are working out. So in 2.2, you should have done all 25 through 42. I think that's problem set 2, right? And then in 2.3, it's just 43 and 44. That's all you need to do. And then problem set 4 will be the rest of it, basically 45 to 60. But I think I threw the 2.3 in with the end of it. Okay. Does everybody feel okay about what's been assigned so far? We just finished section 3 of 4. What did I say at the beginning of the year that we have to do every chapter? Well, you weren't gonna know it was coming. Yeah, that homework quiz, right? We just finished section 3 of 4. Have we done one yet? No. What might be coming here pretty quick?
Next week,
Homework quiz, right? So just like, be ready. I also have a
Do we have Delta Math?
I also have a Delta Math for you guys.
Is it due at the end of the week or next class?
End of the week.
Can we have a week break?
In 2 weeks. Yes. What's that? I'm not doing this with Delta next. Yeah.
You might want to do this one sooner rather than later. It's not terribly difficult. So if you look at this Delta map, there's just 4 problem types. So it's going to be solving side lengths in a right triangle using the Pythagorean theorem. Using special right triangles to find the side lengths in a right triangle. Using trigonometry to find the missing side, just like the example we did. Or using trigonometry to find the missing angle, just like the example we did. Should be relatively easy, but these are skills that I expect you to be able to do well. And I want to get you some practice where you get some immediate feedback of like, okay, I got this still on lockdown, I'm good. I do remember how to do this, and or at least like enough practice where like, okay, I've gotten the rust knocked off, I can do this skill once again. These are things that we expect that we remember how to do from geometry, so I like giving them to you this way where you get some immediate practice where it's like, if you're making a mess out of this, you need to know now, versus the new homeworks, where it's like, if you're making a mess out of that, like that's okay, it's new. Don't expect you to have mastery of it yet. But like these skills I expect to like be able to get back up to speed to be pretty good at it pretty quick. So this is where I'm gonna stop. I'm done talking. I did 63 minutes, that wasn't bad. I think I was done at 59 and I just kept on wagging my gums about the Delta Math and the homework and stuff. If you guys have, so you can now, like, if you're ready to go and you're like, I got this on hand, I got it in lockdown, I'm good. Go ahead and start on working on stuff. If you have homework questions about the stuff that's been assigned so far, I'm going to take those. So if you're working, do your work, no big deal. If you want questions, though, about homeworks that you're not sure on, I'm going to take some of those now to finish out. Of course, yes. So Lucas, I think you said you had...
Yeah, the story problems.
Yeah, do you have one in particular you want to look at?
I didn't ask you to do that. I'm not touching that.
What's that? Okay, we'll get that going here in just a second.
If I get
Yeah, so
You
half the pages are
He didn't have a this one.
I try to hit
Year 1.
That's why Hugo had $100 for sure. He just stood around the whole thing. I know, but I'm so glad. This is me saying I'm not very position.
I have 33.
Yeah,
Yeah, the 83.
I have an 85.
and it was a quiz on my grade.
Wait, what do you have?
Somehow.
83, something like that.
73.
I
Oh, you like this quiz, dude. The actual
Did
thing.
you read the book?
I got 100 on notes because it was so easy. No, they were. Somebody signed this. Look at this. Oh,
Why would you cut it?
I did that yesterday.
I've actually played these.
I can't do
Yeah, that's what I did.
I love the
Bro, I had the greatest training performance of my life yesterday. I scored 4 goals in 2 games. And it's not going to get any more minutes because of that.
My coach saw that and was like, yep, that's the next warmer. I've seen more.
Yeah, bro. Literally. I said, like, let's fucking go after I scored 4 goals. Instead of saying they get nice shots from 4 goals, it's like, don't swear. I'm pissed that Liverpool didn't do that. They're still
Yeah. It just looks nice.
But I have those on.
If I was a keeper, that's an easy save for me.
I mean, you have so much time to see your ball.
I mean,
I'm just sitting in the middle for like half.
well, you can't see with the ball. If you're looking at
Yeah,
the ball, it's
I'll get all my stuff in too.
Send me an email once it's in there so I know you're back.
I will.
Mr. Kulik, if I just turned in my homework like right now, would I still have to send you an email? Or?
Yes.
Oh god,
Because if it's been marked late or missing or incomplete or whatever, like, oh, you need to send me something so I know to go back. Because I would love to imagine I can remember this conversation later.
Yeah.
But I do not have that kind of faith in myself. But if I have to email with that, I will make sure I address it. Because I'll email me like, oh, I got to do that. All right, Lucas. 24 is the one you want to talk about? Okay.
Which one is it?
The first one.
All right. It says a circular saw has a diameter of 8.25 inches. There's 12 teeth per inch on the cutting blade. If the saw spins at 3,500 RPM, how many cutting teeth cross the surface each second? So when I read this, this sounds very much like. Now, yes. Where's my stuff?
For the weekend grades, dude.
The week of grace is community, so
Oh my god. The greatest thing I've ever heard.
I think that'd be funny.
Weekend grades.
It sounds very much like this example 4 problem. So that's going to be kind of what I'm going to be keeping in mind while I'm doing this. So I'm going to start with RPMs.
No.
And it asks me to end in teeth per second. So I'm going to start by converting minutes to seconds.
Same exact thing.
So far, so good. Okay.
Okay.
Now I'm going to convert revolutions into teeth. So I'm given this. I know there's 12 teeth per inch. So somehow I got to get revolutions converted to inches. So I remember from that example in the homework that 1 revolution is equal to 1 circumference. And the circumference is going to be pi times the diameter. And then I know I have 12 teeth per inch. So like minutes cancels with minutes, revs cancel with revs, inches cancel with inches, and I'm left with now teeth per second. I just gotta like grind through the multiply and divide it.
Yeah, that was the part.
How's that now?
Yeah, does that feel okay though?
Yeah.
So just the unit conversion problem, just like the other one, is just about sorting through like, I'm given like a bunch of unit conversions and like
Oh, as long as you
conversion factors. Just how do I use those to get to the-
Yeah.
So again, like breaking down where you're starting, where you end, just kind of like stepping your way through it is the trick.
I actually had
Does that feel good? Yeah. Sure. Do you have another one you want to talk about? Okay. No problem.
I attached to
Okay, so right now, we don't have that.
I pushed my shirt over and I think I got outside told like at least that time.